Okay, let's take a look at chapter 6.1. We're going to talk about discrete random variables. And we know what discrete means at this point. It just means that the variables will take on a countable number of values, such as 0, 1, 2, 3, and 4, so on and so forth. Quick definition here of a probability distribution. Probability distribution of a discrete random variable x. What it does is it lists out the possible values of the random variable, and then of course their corresponding probabilities. And the most important thing that I want you guys to focus on here are the two criteria that the probability distribution has to meet. The number one says that the probabilities must add up. The sum, remember this symbol means sum of the probabilities equals 1, and then the probabilities must be between 0 and 1. And that just means they're non-negative and they cannot be greater than 1. So let's go over here and take a look in the textbook and see if we can get a feel for what probability distributions are. So turn over here to page 330. And we're going to take a look at these guys here. It says determine whether the distribution is a discrete probability distribution. If not, state why. So number 9, excuse me, we've got x, and then we're saying that x can take on the values of 0, 1, 2, 3, and 4. And then we got the probability that, and the way that we write this, let me just kind of show you here. What we say is, let's go back over here. For that question number 9, we might say the probability that x takes on the value of 0 is equal to 20%. And that's the same for 1 is also 20%, 2 is 20%, 3 is 20%, so on and so forth. So let's check both criteria. Number 1, does the sum of the probability add up to 1? So we'll just add these up, 2, 4, 6, 8, 10. So yes, the sum of these probabilities is 1. And then the other thing that we want to check is just to make sure that all the probabilities are between 0 and 1. So this one would be yes. Let me tell you what, while we're going through these questions here, I'm just going to open up this guy over here. And that way I can write down on these what we're actually doing here. Okay. So like I said before, the probability that x takes on the value of 1 is equal to 0.2. The probability x takes on the value of 2 is also equal to 20%, so on and so forth. So criteria 1 says the sum of these probabilities must be 1. So yes, and then all the probabilities are between 0 and 1, decimal numbers between 0 and 1. So yes, this is a probability distribution. So let's try this one over here. All the probabilities must add up to 1. So we got 50, 75, 85, 95, plus 5 is 100. So yes, adds up to 1. And then all the probabilities are between 0 and 1. So yes. Now check this one. Now this one automatically you'll know is not a probability distribution because this probability here is not between 0 and 1. It's actually negative. Okay, this one here, yes, all the probabilities are between 0 and 1. So number 12, yes, is. And this one here, we've got 50, 60, 70, 85. So the sum is 85. So this one does not sum to 1, so no. And then this one, check it. 25, 50, 75, 100, 125, so 1.25. So this one would be no. Okay? So at this point, you definitely should have a good idea of what a probability distribution is. So it just has to meet the two criteria. Number 1, the sum of the probabilities must add up to 1. And number 2, the probabilities must be between 0 and 1. Now, the main thing I want to show you in this section is I want you to be able to find the mean of a discrete random variable. So let's take a look at an application problem. And this is question number 19 here. 2004 baseball season, Ichiro Suzuki of the Seattle Mariners set the record for the most hits in a season with a total of 262 hits. The following probability distribution, the random variable x represents the number of hits Ichiro obtained in a game. So again, we can say the probability that Ichiro, the number of hits x is equal to 2 in a particular game is 2857. So 2857. And so on and so forth. So the probability that he gets 3 hits in a given game is roughly 15%. And what that means is, that means out of 100 games that he plays, out of 100, then roughly 15, he will get exactly around 15 hits. Okay. All right. Now, part A says verify it's a probability distribution. So we just add these up, and they do add up to 1. I've checked that already. So yes, the sum of the probabilities is 1. And so all the probabilities we can just visually check are between 0 and 1. So we're good there. Now, part B says draw a probability histogram. Now, all there is to doing this is just list out the values of x. So I have done that here, 0, 1, 2, 3, 4, and 5. And then the heights here we'll just draw to the probability. So 0, we're at 16%, which is right here above 15%. And then 1, we're at 33%, a little more, so a little more than 33. And then we'll just draw that on down. So that's just like a density histogram, relative frequency. Remember when we did the relative frequency, which means percent? So this is really just a relative frequency histogram. All right, now here's where I want to focus on. So let me give you the formula here. The mean mu sub x is the way we say that, is the sum of x times p of x. So what this formula tells us is we have to have a column called the x column, which we do, and we have to have a column called the p of x column, which we do, and then of course we're going to take x times p of x, which is here. All right, so we started out with this probability distribution here, x and p of x, which is given above, and all we're going to do here to get the mean is we're just going to take x, so we're going to take x times p of x. All right, and then 1 times 3354, 2 times 2857, 3 times 1491 is 4473, 4, and then 5 times 0248 is 124. And then to get the mean, all we're going to do is we're going to add up. This means add this x times p of x column. So we're going to add all these up here, 0 plus 3354 plus all the way down to 0.124, 0.124. And we take the sum of that and we get 1.6273, 1.6273. And that's the mean. This is the mean of a discrete random variable. All right, so now the variance, okay, so compute the, and I've actually done that right here. This mu of x is equal to the sum of x. So you just add those up, you get the mean. Now, compute the standard deviation. We're going to use this formula, which is sigma squared sub x is equal to the sum of x squared times p of x. This is multiply x squared times p of x minus the mean squared. So that means we have to get a column called the x squared times p of x column. So let's go back up here, and that's why we get this x squared times p. And all we're going to do here, again, is, if we can get rid of this yellow highlighter. Okay. All right. So it looks like I erased it, right? All right. Okay. Let's see if it stroke eraser. All right. So here's what we're going to do. We're going to take x and we're going to square it and we're going to multiply by p of x. So 0 squared is 0 times 16 is 0. 1 squared is 1 times 3354 is 3354. 2 squared is 4. 4 times 0.2857 is 1.1428. And then 3 squared, remember we're taking x and then we're squaring it and then we're multiplying by p of x. So we get 3 squared is 9. 9 times 1491 is 1.13419. And then 16 times 0373 and then 25. All right, and so we're gonna add this up again. So the sum of this column here, so you add all these up and you get this 4.03, and that is going to be the sum of x times p of x, right? That's here, okay? And then of course mu of x is here, the mean, which we just got. So what we're going to do is we're going to take the sum of x times p of x, which is here, and we're going to substitute it into this piece of the formula. And then of course we know that we got mu of x a second ago. So mu of x, and that's going to go right in here. And don't forget to square it. So we get 4.0369 minus the mean, which is 1 point, and then all right, and then we take the difference there, and we get this number here is called the variance. How many of you remember how to get the standard deviation? Yeah, we just take the square root of the variance. So the standard deviation is the square root of this 13888. Okay? And that's all there is. And that's kind of, like I said, that's the main thing I want to show you here for 6.1 is just how to find the mean and the standard deviation of a probability distribution. Now, part E just says what's the probability he got 2 hits. Well, this number here, probability he gets 2 hits in a given game is 2857, and that's just from looking right here off the chart. 2857. And then the other part says what's the probability he got more than 1 hit? Well, we just add them up. So more than 1 means 2 or more. So we just add up the probability of 2 plus the probability of 3 plus the probability of 4 plus the probability of 5. And we add all those up down here. And we get probability 2 plus 3 plus 4 plus 5. And we get that's the solution right there. All right. So now that we've done this kind of problem where the distribution is given, let's look at one where it's not given. Okay. And these are kind of interesting because they deal with actuarial science, which actuaries do probability and statistics for insurance companies. So we got an insurance company sells a $250,000 1-year term life insurance policy to a 20-year-old male for $350. So that first statement means this: the 20-year-old male goes down to the insurance company and gives them $350. Okay, and if he lives throughout the year to see age 21, then the insurance company just keeps his money. They just keep his $350. If he does not live, then the insurance company pays out this big lump sum here, $250,000, to the beneficiary, whoever that is. Okay, and we want to know what is the expected value of this kind of policy, right? And if it makes sense to you, most of the time, the insurance company is just going to keep the $350 because 20-year-olds normally live, right? So it's kind of common sense. And so what we're going to do is we're just going to look at 2 cases here. 2 things can happen. He can either survive or not survive. If he survives, then X, the net profit, to the insurance company, X would be $350, right? Because they keep it. If it does not survive, then the net profit, there's not no net profit, right? They're actually losing money, a lot of money. So we have to figure out, do we do 350 minus 250,000 or 250,000 minus 350? Well, we do 350 minus 250,000, right? Because we want the result to be negative because they're losing a bunch of money. So the net profit, if he does not survive, is minus 249,650. Okay, and so now we got two values here. Net profit is positive 350, or they lose this money, they pay out this. And so the probability that the insurance company makes 350 is just the probability that he lives. And we're told in the question here, the probability the male survives the year, right? Survives the year is really good, 998,734. Okay, so how do we get the probability he does not survive, which is down here? Survive and not survive. Not survive, we just take 1, so the probability that he does not survive is just 1 minus the probability that he survives. 998,734. So we get this number here, 001266. 001266. Okay. And so now to get, remember we're trying to get the mean, so we need to take the sum of x times p of x. All right, and so we're going to create a column called the x times p of x column, which is here. And we just multiply this number times this number and this number times this number. Make sure you pay attention, negative times a positive is a negative, left off my negative sign here. And so now we just add these up. 349, 5569 minus 316, 0.0569. And we get roughly, what is that, $33.50. 316. Yeah, $33.50. So $33.50. Okay, all right. So now let me show you something here. I'm going to show you one last thing here, and I'm going to show you how to get the mean of a probability distribution for your homework, because I want you to be able to do that. And this is, you'll like this. This is one here. And let's just take that one, number 10, that we looked at before. So the first thing we want to do is go to Stat and edit our list. And then we'll type in, and this is number 10 on page 330. So let's go ahead and type in X, which is 0, 1, 2, 3, 4, 1, 2, 3, 4. All right, and then arrow over, and we'll type in our probabilities here. 0.1, 0.5, 0.05, 0.25, and 0.1. All right, so here's all there is to getting the mean. We just go to quit there, and then we're going to go to Stat. We're going to go over to one variable stats, and we're going to do our list is L1. That's the X values, and our frequency will go down here, and we'll hit second to L2, and then enter. And for those of you who don't have the list here, you'll just enter, when you go to one variable stats, you'll just enter L1 comma. You'll just put a comma in L2 and it'll calculate it for you. Okay, so here you have the standard deviation, and you've got the mean here, okay, for that probability distribution. And so that will help you getting the variance and the standard deviation for a, you got the mean and then the standard deviation here. Okay, that is 6.1. So I'll see you guys for 6.2 here shortly because I will be missing. Um, Actually, I'll be missing uh, Thursday and Friday of this week, and then Wednesday, Thursday, Friday of next. So I will be posting all these lectures that I'd normally do in class. I'll just post them to eLearn here. So uh, hope you guys have a fantastic week, and I'll see you guys when I get back.